the second part of our video, we will discuss another example which the graph itself will be different with the first example. Since the transfer axis will be different, the orientation will be on the vertical. So before that, I will discuss another example from the textbook, which is it will be entirely different with the result if we compare to the first example. So this is it. Example number 2. You can see the equations, and we can definitely know this is hyperbola since the A is 9 positive and the B is negative 1. Okay, so they are different in signs, so we can be sure it is not a ellipse, it is not a circle, it is a hyperbola. So since we need to graph this, the first objective is to convert this equation into the general form of hyperbola. And we don't know, again, we're still open for these two options. Either the final form will be on the first one or the second one. So let's do the steps. Okay, let's skip the graph first. We save it for later. The steps, the first one, since we need to, it's almost the same like before. So we need to subtract both by 302 because we need to make a number, of course, on the right member. So this is the final result for the first step. And then the second one, we change the order, just like the same. I make it faster for now. And then the third step is excluding the coefficient of the squared variable. So the squared variable, which is 9, we exclude from the first two terms. And from y squared, the coefficient is negative 1. So we need to exclude negative 1 from the third terms and the fourth term. So the result will be like this. Notice that I still write the 1 here, although it's not necessary. You can just eliminate 1 since it's the same, but I will skip that number on the screen. So since you need to be careful with the sign, since I need to exclude negative 1 from this, I need to divide 4y by negative 1, so the result is negative 4y. You change the sign. It's very tricky with the sign. I need you to be careful with this. And then we complete the square inside the parentheses. So we have this and this. It means we need to add a number. We have to force it since we need to complete the square. It means when we add something, we add numbers on the left member, we have to add also on the right member. So since I add 25 here on the left and 4 here, which is not there before. So when I add 25, I need to multiply with 9 since this is the coefficient. So I have 225. And since I add 4 here, I need to multiply by negative 1. So it becomes negative 4. Okay, so in the end, I factor and simplify. And then this is the result. Okay, this one all will be negative 81 on the right member, and then the factor thing, of course, you already understand. And the last one, since I need to make 1 on the right side, positive 1, and we have negative 81, so we have to divide both sides by negative 81, negative. So since I divide all by negative, there will be a change of sign here. So before the x have positive coefficient, now the x fractions have negative coefficient. And since the y I divide by negative also, so originally it's negative and then divide by negative, it will be a positive. So when I simplify it, this is it. I will have the second form of the general form. See, the negative belongs to the fraction of x, not the y fraction. So, and I will just try to match the general form. This is the general form. You can use either this one or this one. But the thing is, we can have a different situation from the first example, which is, this is the conclusion. It will be a hyperbola, of course. The center will be 5, 2. the x radius will be 3 units and the y radius will be 1 units, and sorry, 9 units. And then the transverse axis is the vertical. Since the positive belongs to the y fraction, it means the transverse axis will be vertical, follow the y. And the conjugate axis will be the horizontal one. Okay? And then we haven't discussed this before. Since we need to graph after this, I will introduce you with the slope of the asymptotes. Since hyperbola will have asymptotes line which has a slope, so the slope will be 3 and negative 3y. You can refer to the textbook. Actually, 3 comes from the ry divided by rx. Okay, it will be both positive and negative. Okay, but I will discuss this later on the graph. So let's go to discuss about the graph. From the first example, we can see that this is the final answer. Okay, the original equations in the quadratic relation is this, and then after we convert, and then we have this general form, and from this we can see that the center is 2, negative 3, and our x is 4, our y is 5, and the asymptotes of your the slopes of your asymptotes will be this one. I will explain you later. So to graph a hyperbola first begins with the center. Since the center is 2, negative 3, so let's point the center first. 2, negative 3. Here is the centers. So the center will be the cross-section of your transverse axis and your conjugate axis. Now, we have already mentioned about transverse axis. Now, this is the application. The transverse axis, since the positive belongs to the x fraction, the transverse axis will be horizontal. It means horizontal, the vertex and your foci of your hyperbola will be on the horizontal axis. So before we go there, let's make the axis first quickly here. From the center, since we know that the Rx or the radius x is 4, you just plot 4 units, 1, 2, 3, 4 to the right, and 1, 2, 3, 4 to the left. Okay, since this is the transverse axis, the vertex is, you count 4 points from the center, since the 4 points is the x radius. The ry, the 5 points, you count from the vertex, not from the center. To the top, 1, 2, 3, 4, 5. This is another one. And then 1, 2, 3, 4, 5. Okay. From the other vertex, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Now, these 4 points, this is the guidance for our asymptotes. So let's connect this center and another point to have an asymptote line. Now we have another this, and this. This is another asymptote of your hyperbola. This is the transverse axis, this is the conjugate axis, this is the vertex, this is the vertex bola. So if I need to sketch it, I will do this. So, keep in mind, because this is the asymptote, it means your curve, it is getting closer to the asymptote but never touch. That is the condition of your asymptote, right? So
this is the most left, so let's graph this one also. It's getting closer to the asymptote but never touch. I will just put an arrow here.
So this is our first curve, and this is the vertex. It means this is the most left. So how about this one? It's the same, but this is the most right. Another curve. So the conjugate axis, this is the conjugate axis. The conjugate axis, it is like the mirror of your hyperbola.
the transfer axis is the axis that breaks through your hyperbola. I hope that is more understandable. Okay, yeah. So this is your hyperbola. Which one is the hyperbola? Only this one and this one. This is the asymptote. This is the axis. So the graph itself, only these two curves. And the transverse axis, this is the horizontal. Why? Because the transfer axis always refer to the positive fraction. So the positive fractions belongs to the x. It means the x is the transfer axis, not the y. Okay.